In 1893, engineers at the World's Columbian Exposition in Chicago unveiled what they called the largest flywheel ever constructed. It was a 75-ton rotating mass capable of storing enough kinetic energy to power entire city blocks. The press celebrated it as a triumph of modern engineering. But buried in technical journals from the same decade, engineers admitted something troubling. They were not inventing this technology, they were reconstructing it. Across Eastern Europe, Central Asia, and the ruins of pre-modern industrial sites, enormous stone and metal wheels had been discovered. Precision machined, perfectly balanced, far too advanced for the civilizations credited with building them. These devices stored rotational energy without fuel, without combustion, without dependency on external power grids. They represented a form of decentralized, self-sustaining energy infrastructure. And yet, by the early 20th century, almost every known example had been dismantled, melted down, or reclassified as decorative architecture. If these spinning giants truly existed, what kind of civilization built them, and why did they disappear? The story we are told begins in the workshops of 18th century Europe. According to mainstream engineering history, flywheel technology emerged as a direct consequence of the Industrial Revolution. The accepted narrative credits James Watt, the Scottish inventor and mechanical engineer, with pioneering the practical application of rotating mass for energy storage and regulation. I examined the standard academic sources. Textbooks describe how Watt, working to improve steam engine efficiency during the 1770s and 1780s, implemented flywheels to smooth the irregular power output of early piston engines. The flywheel absorbed energy during the power stroke and released it during dead points in the cycle. This innovation transformed unreliable machines into steady, productive engines of industry. The historical record presents flywheel development as linear and logical. After Watt, engineers throughout the 19th century scaled the concept. Larger wheels, heavier masses, more sophisticated bearing systems. By the time of the Great Industrial Exhibitions in Philadelphia in 1876, Paris in 1889, and Chicago in 1893, flywheels had become symbols of mechanical progress. They grew to enormous proportions, weighing tens of tons, spinning in purpose-built halls, and demonstrating the raw power of Western industrial achievement. I found that contemporary accounts framed these devices as uniquely modern. Writers described them as products of scientific enlightenment, triumphs over the primitive past. The message was clear. Before the Industrial Revolution, humanity lacked the knowledge to store and regulate mechanical energy at scale. Flywheels represented a decisive break from pre-industrial limitations. This narrative served multiple purposes. It established European technological supremacy. It positioned industrial capitalism as the engine of human advancement. And it created a convenient boundary. Everything before was primitive. Everything after was progress. Yet when I examined the technical literature of the period more closely, I noticed something peculiar. The engineers writing in specialized journals occasionally referenced ancient precedents and rediscovered principles. These references were brief, almost embarrassed, quickly overshadowed by celebrations of modern achievement. But they existed. The official history does not account for these admissions. It does not explain why engineers would describe their innovations as reconstructions rather than inventions. It does not address the persistent reports of massive rotating structures found in ruins across multiple continents, structures that predated Watt by centuries, possibly millennia. The accepted narrative provides a coherent story, but coherence is not the same as completeness. And as I examined the evidence more closely, I began to understand why certain questions were never asked, and why certain answers may have been deliberately buried. The first anomaly I encountered came from an 1872 survey report filed by a Russian geological expedition in Central Asia. The team, mapping mineral deposits in what is now Kazakhstan, documented the discovery of a massive stone disc partially buried in an eroded hillside. The disc measured approximately 12 meters in diameter and showed evidence of precision machining. Perfectly circular, with a central borehole and radiating channels cut into its surface. The expedition leader noted that local populations referred to such objects as the wheels of the old ones. They appeared at irregular intervals across the steppe, always partially buried, always showing the same machining characteristics. The report was filed, archived, and never formally published. I traced similar accounts across Eastern Europe. In the 1880s, Austrian archaeologists excavating pre-medieval sites in the Carpathian region documented underground chambers containing enormous metal rings. These rings, forged from an alloy that resisted corrosion, featured precision-bearing surfaces and mounting points consistent with rotational machinery. The archaeologists classified them as ceremonial objects of unknown purpose. The pattern extended further. In Turkey, remnants of rotating stone platforms were found beneath Byzantine-era construction. In northern India, British colonial surveyors recorded massive granite wheels in temple complexes, wheels that showed no evidence of religious iconography, but featured engineering specifications more consistent with industrial equipment. I examined photographic archives from the late 19th and early 20th centuries. Several images showed enormous wheels and discs in states of partial excavation. The captions typically described them as ancient artifacts, without further elaboration. In some cases, subsequent photographs of the same sites showed the objects removed entirely, with no record of where they were taken. What struck me most was the consistency of the engineering. Despite appearing across vast geographical distances and in ruins attributed to unrelated cultures, these rotating objects shared common design features. Central bore holes of similar proportions, radiating channels that suggested energy distribution pathways, mounting points consistent with sophisticated bearing systems. The official explanation, when one was offered at all, we classified these objects as millstones, pottery wheels, or religious symbols. But the scale did not match these explanations. A 12-meter stone disc is not a practical millstone. A precision-machined metal ring with bearing surfaces is not a decorative object. The archaeological record contains evidence that does not fit the accepted historical framework. Massive rotating structures appear in pre-industrial contexts, demonstrating manufacturing precision that should have been impossible for the civilizations credited with creating them. This evidence raises an uncomfortable question. What if flywheel technology did not originate in 18th century Europe? What if it was far older and far more widespread than we have been taught? As I continued my investigation, I moved beyond individual artifacts to examine the architectural contexts in which they appeared. What I found suggested something more significant than isolated objects, a coherent pattern of rotational infrastructure embedded in building design across multiple continents. The first architectural element I identified was the underground bearing chamber. At several sites in Central Asia and Eastern Europe, excavations revealed subterranean rooms with reinforced floors featuring circular depressions. These depressions showed polishing consistent with sustained rotational contact. The chambers included ventilation channels and drainage systems, features unnecessary for static storage but essential for managing heat and lubrication in mechanical systems. Above these chambers, I found evidence of axle mounts, stone or metal brackets anchored to foundational walls, positioned to support horizontal shafts extending from central rotating masses. The mounts appeared in pairs, spaced at intervals consistent with large-scale flywheel installations. In several cases, the brackets retained traces of bearing material, a polished composite that reduced friction during rotation. The counterweight systems were equally revealing. Many rotating platforms featured asymmetric mass distribution, deliberate imbalances that would make no sense for decorative or religious objects, but served a specific mechanical purpose. Counterweights allowed flywheels to maintain stable rotation, even when energy was extracted unevenly. This was not intuitive design. It required understanding of angular momentum and harmonic dynamics. I also identified what appeared to be harmonic stabilization features. At sites in the Caucasus and northern India, rotating stone masses featured precisely spaced notches around their circumference. These notches were not decorative. They were tuned to specific frequencies. When the mass rotated at certain speeds, the notches would interact with stationary pins or dampeners to reduce vibration and maintain stable spin. This technique is used in modern flywheel systems. Finding it in pre-industrial ruins raises significant questions. The consistency of these design elements across distant locations troubled me. Civilizations separated by thousands of miles and, according to official chronology, hundreds of years, employed the same engineering principles, the same bearing chamber proportions, the same counterweight configurations, the same harmonic stabilization features. This pattern suggests one of two possibilities. Either multiple independent civilizations developed identical solutions to the same engineering problem, a coincidence difficult to accept, or a unified knowledge system once existed that transmitted rotational energy principles across vast distances. The architectural evidence points toward infrastructure, not art. These were functional installations designed to store and distribute mechanical energy, and they appeared to operate within a coordinated network that spanned continents. The question was no longer whether this technology existed. The question was how it worked and what it was used for. The physics of flywheel energy storage are well understood. What remains uncertain is the extent to which earlier civilizations applied them. A flywheel stores energy through angular momentum. When a mass rotates, it accumulates kinetic energy proportional to its moment of inertia and the square of its rotational velocity. This energy remains stored as long as the wheel continues spinning. It can be extracted gradually by applying resistance, powering machinery, generators, or mechanical systems. The primary advantage of flywheel storage is independence. Unlike chemical fuels, which require continuous supply, a flywheel stores energy in pure physical form. Unlike electrical batteries, which degrade over time, a properly maintained flywheel can operate indefinitely. The only requirements are minimal friction and periodic input to overcome air resistance and bearing losses. I examined how such systems could function at municipal scale. A large stone or metal flywheel, spinning in an underground chamber with optimized bearings, could store enough energy to power industrial equipment for extended periods. Multiple flywheels, connected through mechanical linkages, could form distributed networks, each installation storing and sharing energy as needed. The materials required for long-duration spinning are not exotic. Dense stone such as granite or basalt, carefully quarried and balanced, provides excellent mass for energy storage. Metal alloys reduce bearing friction. Underground installation protects against environmental interference and maintains thermal stability. The evidence I found suggests that rotational energy was accumulated through several methods. Wind-driven input mechanisms appear at some sites, large vanes or sails connected to flywheel axles. Water-driven systems appear at others, channels directing flow against paddle wheels linked to central masses. And at some locations, I found evidence of what appeared to be manual acceleration systems. Human or animal power applied through geared mechanisms to bring flywheels up to operational speed. Once spinning, these systems could theoretically power manufacturing operations, textile production, metallurgy, agricultural processing. The flywheel would provide steady, regulated energy, smooth output regardless of variable input. But the implications extend beyond manufacturing. A network of decentralized flywheel installations would represent something more significant. Energy independence at the community level. Each town, each district, each region could store its own power without reliance on external fuel supply or centralized distribution systems. This is where the technology becomes significant, not as a danger to people, but as a threat to certain economic and political structures. Decentralized energy storage undermines the dependency relationships that characterize modern power systems. It challenges monopolies built on fuel extraction and distribution. It enables self-sufficiency that conflicts with centralized control. I began to understand why this technology, if it existed at the scale suggested by the evidence, might have been deliberately suppressed rather than celebrated. The transition from distributed flywheel infrastructure to centralized fossil fuel systems did not happen gradually. The evidence suggests it occurred through deliberate dismantling, often framed as modernization or reconstruction. I trace the fate of documented flywheel installations through the 19th and early 20th centuries. The pattern was consistent, following political upheavals, wars, or administrative reorganizations. Obsolete machinery was removed from public spaces and industrial sites. Metal components were melted for scrap. Stone masses were buried, broken, or repurposed as building foundations. In Central Asia, Soviet industrialization programs systematically removed what internal documents called remnants of the old technical order. Engineering teams documented these removals but classified the reports. The machinery was described as primitive and inefficient, yet the resources devoted to its destruction suggested otherwise. In Eastern Europe, similar patterns emerged following the world wars. Reconstruction efforts prioritized centralized power systems, coal plants, electrical grids, petroleum infrastructure, pre-existing mechanical installations, including documented flywheel sites, were demolished to make way for modern development. The official justification was progress. The practical effect was dependency. I found evidence of deliberate reclassification. Objects that earlier surveys had documented as mechanical equipment were redesignated as religious artifacts or decorative architecture. This reclassification served multiple purposes. It removed the objects from engineering discourse. It prevented technical analysis, and it obscured any continuity between ancient technology and modern rediscovery. The destruction was not universal. Some installations survived in remote locations, too distant for efficient removal, too buried for easy access. Others were preserved through local concealment, communities recognizing value that official authorities denied. But these survivors were exceptions, not representatives. I examined the economic context of this dismantling. This the transition from decentralized mechanical energy to centralized fuel-based systems created new power relationships. Communities that had maintained independent energy infrastructure became dependent on external supply chains. Resources that had been locally controlled became commodities traded through centralized markets. The suppression was neither accidental nor inevitable. It represented a choice to replace self-sufficient systems with dependent ones, to substitute distributed power with concentrated control. The spinning giants were not abandoned because they stopped working. They were removed because they worked too well, and for too many people. Today, flywheel energy storage is returning, but it is returning as innovation, not remembrance. I visited modern flywheel installations in Europe and North America. Data centers use spinning carbon fiber rotors to provide backup power. Electrical utilities deploy large-scale flywheels to stabilize grid fluctuations. Transportation engineers experiment with flywheel systems for buses and trains. Regenerative braking that stores energy in rotating mass. The engineers I spoke with described their work in familiar terms: cutting-edge technology, solutions that would transform energy infrastructure. None mentioned historical precedents. None acknowledged that the principles they applied might be centuries or millennia old. I examined the technical specifications of modern flywheel systems. Underground installation for thermal stability, precision bearing surfaces for minimal friction, harmonic stabilization features to maintain smooth rotation, distributed networking for shared energy management. Every specification matched what I had documented in the archaeological record. This parallel raises a question that modern engineers seem unwilling to address. Are we inventing the future, or are we slowly reconstructing a past that was deliberately erased? The evidence I have gathered does not permit definitive conclusions, but it suggests a pattern that deserves serious investigation. A sophisticated technology for storing and distributing mechanical energy may have existed before the Industrial Revolution. This technology may have been systematically dismantled during the transition to centralized fossil fuel systems, and today, the same principles are being reintroduced without acknowledgement of their possible origins. I do not claim certainty. The historical record is incomplete, possibly intentionally so, and the physical evidence has been scattered, reclassified, and destroyed. What remains are fragments, suggestive but not conclusive. But fragments can tell stories, and the story these fragments suggest is one of forgotten capability, deliberate suppression, and slow rediscovery. The spinning giants may have fallen silent, but the questions they raise continue to turn, waiting for those willing to listen.